Hello everyone, welcome back to my channel. Today let's go over a Leetcode hard question that I just solved on my own. So I'm really happy about this. I don't know how I was able to solve it on my own without any assistance today, but I just sort of looked at it today, and because I struggled with this a long time ago, and today for some reason I just came here and I was like, okay, let me just get all the subarray sums, use a couple loops, and then I was able to solve it on my own without any assistance. So I'm really surprised about that and also happy about that. So let me show you how I did it. So this one's called maximum sum of 3 non-overlapping subarrays. The question itself is not too hard. Just find subarrays of size k that are non-overlapping that have the largest sum, and then within those sums find the smallest starting index of those sums. So 8 or 3, 8 and 12, 0, 3, and 5 in this case. So as long as they're k apart, they're non-overlapping, right? So the first thing I did was to just go over nums and get every subarray sum of length k. So from left to right, sum. So minus k plus 1. And then let's just make a subarray sum array called current, and we're just going to append the sum of nums of I plus k. Let's print current. Cool. So now we have all the subarrays of size k, or the subarray sums of size k. Now what we want to do is to start from k, because that's the first point where it's non-overlapping, right? And then go up to here because that's the last point where it's non-overlapping, because that's the last subarray of size k that's equal, right? So we're just going to do for I in range k to length of nums minus k. And then we're just going to call this the left side is nums of up to I minus k. The right side is nums of I plus k to the end. So let's print left nums of I and then right. Okay, or let's do this for current because we care about the subarray sums. We don't care about nums anymore. Okay, so 3 is supposed to still have 1, so plus 1 it seems. Cool, so now we got this, and we got, so here, what do we got, 12, I plus k plus 1, 3, so we're starting here, we want 13, 12, and then 6. So we're gonna make that equal, okay, cool. So now that makes it easy because we can just calculate the actual answer, which is supposed to be the largest 3 subarrays. So let's take care of that first before we worry about the smallest index. So obviously the biggest is going to be max of answer of, so the left side is just going to be max of left. Current is going to just be current of I, and then the right, so this plus whatever is the max on this side. And we do that at every iteration. This time it's going to be 3, 8, 12. That's the biggest. You can only pick one element from each side, right? Right side is max of right. So left side plus current of I plus right side. And if we print our answer, let's see. Minus k plus 1 maybe. Okay. Minus 1 maybe. Okay, cool. So now we get 23. You can see that's correct. 3 plus 8 is 11 plus 12 is 23. So now that we have what we want, we can just do this whole thing again, right? Because now we just want to find the index of whatever is equal to that. So for I in range, k to length of nums minus k minus 1. Again, the left side is current of up to I minus k plus 1. The right side is current of I plus k to the end. And again, let's just print left, current of I, and right. We don't want to print it twice. Let's get rid of this. And now we just find the index, the lowest index, because dot index finds it. So the max left is again going to be max of left. Max right is max of right. And the current is just going to be current of I. So let's print max left, current, and max right. And we know, again, because we did it here, that eventually like this is going to be equal to this sum. And so we can just say if max left plus current plus max right is equal to answer, then we just find, and it gets a little tricky here because obviously max left is fine. So the left index is just left dot index, the leftmost index of 3. So here that's going to be 0 of left value or max left. And then the current index is just going to be I, obviously, right? And then the right index is where it gets challenging. So for j in range, what is it? I plus k to length of current. So all the way to the end. So for example, here we can say either these two, whichever one. So we already have this plus this, whatever makes the difference, right? So if left plus, if max left, the value, this is the index, plus current value plus current of j, because we already have the k constraint, right? At least k away is equal to answer. Then what we can do is add this into a sorted list because we want the lowest index that has the biggest sum, right? So sl.add left index, current index, and then j. And then since we found the lowest index, the leftmost one, because for example here, if we have 3 multiple times, we want the leftmost 3 on the right side. That's at least k plus k away from the current I, right? And then we just break it. So at the end, we can just return SL of 0, right? Because that's just going to give us the lowest index that has the biggest sum. I hope that makes sense. So let's run this. Submit it. Okay, so if right, let's do this. What the heck? If right, I feel like I might have messed some of these edge cases up. So I plus k, is it minus 1? Plus 1. Plus 1. Okay. Maximum of right is if left and right, right. If left and right do this, right, that's the only time it counts. So submit this. Okay, cool. So now at least we got the brute force solution. This is n squared because of the extra loop, the nested loop here. Okay, almost there. So what I did was just, this is really slow, so let's just create a prefix array. Iter tools.accumulate nums, because to get a particular subarray sum, again, it's just the prefix of this minus the prefix before. To get this subarray sum, the prefix of this minus this to get this, for example. So if I is less than or equal to 0, the now is just p of I plus k minus 1. The current one, because there is no left side here. Otherwise, now is p of I plus k minus 1 minus p of I minus 1. And then you just append now. Okay, that makes it a little better. So submit this. And there you go, passes all test cases. So again, I'm really happy I was able to solve this one on my own because this is a hard question. And yeah, even though it's not the most efficient, it is my own work. So I'm proud of that. And that's it for this video. Thank you for watching and stay tuned for more.